Guys, we're moving on, and that means we're getting closer and closer and closer to the end of the lecture video series, and I know that's something that you can't wait for, right? So in this video, we're going to focus on the suppressor of the IC system. This is kind of what makes ion chromatography different from some of the other liquid chromatography systems that are out on the market. The IC system has to have a suppressor. We've already talked about the problem with the baseline. We've talked about the problem with anion chromatography in particular. The baseline has to be basically 0 or something close to it at least, and that's the purpose of the suppressor. It's to take all of the anions out of the mobile phase or the cations out of the mobile phase, and it removes them. And it gives you a very clean eluent that comes out of the system after that point in time. Okay, so a couple of things about the suppressor that I like for you to kind of remember. Whenever I think of suppressor, for some reason, I kind of think of a suppressor on a gun. It makes it go silent, right? Or silencer. So this basically is going to be lowering the noise that the gun will make. The same thing's going to happen with the ion chromatography system. The suppressor is going to be installed in the machine, and that suppressor is going to lower the noise. But it's the noise of the background. It's the noise of the detector. It's the noise of the mobile phase, right? So the mobile phase has these ions. The ions, if they stay there, is going to create some conductivity. And if you're not careful, the poor little ions that you're trying to measure will not go higher than that because it's already elevated. So you just got to kind of make sure that your system is close to 0 as possible as far as your detector goes. So, the closer you are to 0, the lower you can get in concentration unit. So that's something that you want to keep in mind. If you are needing very, very low part per million levels, or if you want on the part per billion level, then you need a baseline that's going to be close to 0, and you need a suppressor that will be able to do that job for you. So suppressor is going to be very important as far as how low can you go with your samples, which is kind of what we would call sensitivity in a way, right? So better the suppressor, the better the sensitivity, the lower in the concentration that you can get. And now all of a sudden your lab might be better than someone else's lab because you can go much lower than they can. What I want to start off with is showing you a picture of what the suppressor looks like. And the reason that I like this one, I know this is a golden oldie picture at this point in time, but it puts the suppressor kind of up front and center. And what you're seeing here, right up here at the very top, this is your suppressor unit. Okay, this is the piece that we're getting ready to talk about now. So if you open up the door to a modern Metrome, at least, ion chromatography system, you're going to see this white circle that's stamped with a 1, a 2, and a 3 on it. And this white circle is going to be the house for your suppressor. So that is not the suppressor. You would unscrew the cap off of that suppressor, and on the inside would be the actual suppressor cartridge. Okay? And again, this is just for Metrome. Some of the other IC systems out there, they still run off of membranes, and those membranes are made a little differently than the Metrome suppressor that you're seeing here in front of us. But I'm focusing on Metrome because that's the machines that we have in our lab, and that's what we're going to go with. So there's your suppressor unit. Very simple and easy to pick out in a picture or a diagram. So if I give you a picture like this on a test, I'll say circle the suppressor. Right? And hopefully you would go to this and you would say, look, right there it is. Kind of hidden right there. I see the 2. I see that kind of white circle shape. So right here is going to be my suppressor unit. I would also give you a picture like this and I would say, where's the purge pump? And you would look at this thing right here and you go, hey, look, right there on the side, there's the piece of tubing that comes out. I can put my syringe in right here. So this is going to be the purge. And then I'll say, where's the main pump? Right there it is. We talked about that main pump. So here's the pump of the system. And then I would say, where's the loop? And you would look at this and you would go, oh, look right there. Right here's the loop. Right there it is. And there's a tag on it. And that tag actually said 10 microliters. That's a 10 microliter loop installed on this machine. And then I would say, where's the injector port? This whole contraption right there. There's the injector port. That's where all the tubing comes in. My mobile phase comes in. My mobile phase goes out. My sample comes in. My sample comes out. You do the hokey pokey and you turn yourself around, right? All right, so those are the pieces and parts of the machine that we've talked about. And there they are. And of course, this guy right here, that's our column. So don't be surprised if I give you something that looks like this on the test. And it'll be a real picture with real pieces and parts, not a silly looking diagram. And I'll ask you to kind of pinpoint what various things are and where they're located. All right. So again, all of this led because we're getting ready to talk about the suppressor unit, which is right there in the back. If I unscrew this cap off the top and I pop this out, there's going to be a cartridge on the back side of this. And that cartridge can slide out and be changed out. That is your actual suppressor. What that cartridge looks like is something that looks like this. So on the front end, right there, that is what we need to see. So this is the front of the suppressor. And notice there's 1, 2, 3, 4, 5, and 6 holes right here in the very front. Those 6 holes are very important. The reason is because 2 of these are going to be used for your eluent, which is the mobile phase and your sample. Okay? So keep that in mind. But you know, there's other things that are going on in the suppressor too at the same time. So 2 more of these are going to be used for the acid. And this acid is going to be used for the cleaning. And again, we kind of mentioned this before in the past, so it's going to come back and haunt us now. And then the other 2 holes, well, you kind of guessed it if you were paying attention. It's going to be DI water. And that is the DI water in and DI water out. And that is for your rinsing. So eluent goes into one and eluent comes out of the other. And then acid goes into one and acid comes out of the other. And water goes into one and water comes out of the other. And that's why there's 6. And again, the Metrum suppressor is divided up into 3 channels. And that is why. Channel number 1 is your eluent and sample. Channel 2 is going to be acid clean. And channel 3 is going to be your DI water. All right? So that kind of gives you maybe a head start on the suppressor and what we're going to get ready to see in the suppressor discussion that's getting ready to come up. All right, so that's where I'm going to stop the video, and in the next one we'll start picking apart some of the theory and some of the lecture tidbits that I would like for you to walk away from understanding the purpose of the suppressor and how it does its job, and maybe to how to clean it and to take care of it.